Hey Hamilton students, I'm going to kind of go at this a little bit from what we did today, and this is a quick video on not only long division, and I do mean a quick video, I'm going to give you one example, but kind of some informational and material and a little bit of an example of synthetic division, which we didn't get to, and I'm going to try cover next Monday, but it might be a good idea to preempt your exposure and take a look at this video, and I'll try to do it pretty quick. Let's say I have this higher degree polynomial. We know it's a higher degree, at least what we consider a higher degree, because the highest term, this is a 3, the power of 3, or higher, right? So this is a third degree or higher, and we have a hard time factoring these. We have a hard time doing a number of things because, well, we haven't practiced. So one of the ways we can factor is, to graph it. And let's suppose we graph this. Alright, and I can see that one of my roots, when I graph this, one of my roots crosses, and I can check that like I showed you, but we'll say one of our roots, and we'll call our root a 0. Right? We'll say one of our zeros that we know crosses at -1. That's one of our roots. We know that that would make a factor of x plus 1. Because if I said x plus 1 equal to 0, the answer is going to be a -1. Alright, so those are my roots, and that's how that works. Well, hey, when we get one of our factors, we can find other factors by taking this and dividing it into the polynomial. And since this is in fact a factor, this is one of those situations of this larger polynomial, then we should not end up with a remainder. So as long as we do everything correctly, long division, we should not end up with a remainder. I want to point out one other thing. This factor is actually linear in nature, and we know that because the x here is to the first power. So, and because it's linear in nature, that's going to afford us the opportunity for a shortcut synthetic division, and I'll show you that pretty soon. Let's go ahead and do this long division. I've got x plus 1. We're taking x plus 1, alright, we're going to divide it into x cubed plus 2x squared plus 4x plus 3. And here I go. Again, I'm concerned with my first terms. I want to turn x into x cubed, so when I subtract they cancel out. And that is going to be a multiple of x squared. X squared times x is x cubed. X squared times 1 is just 1x squared, and I'm going to take all of this and subtract it, much like long division. These guys cancel out. X cubed minus x cubed is 0, and 2x squared minus 1x squared is just 1x squared, or just x squared. And we'll drop down our next term. Hey, what determines how much I drop down is the fact that this is a binomial, so I need to deal with at least a binomial in here. And remember, much like we talked about and are on your notes, if there are any gaps, let's say this 4x wasn't here, and I went straight from x squared to a constant, or x to the 0 power, I would have to fill in 0x here. Alright, if you're unclear about that, please talk to me. You are going to have to know how to do this. So, I asked myself the same question. I have this x, and I want it to turn into x squared, so I'm going to have to multiply that entire binomial by x. X times x is x squared. X times 1 is just x. And once again, I need to subtract. Well, x squared minus x squared is a 0, and 4x minus x gives me 3x. And now we can see that this is in fact a factor. Alright, so if there was any indication that it may not be a factor, which we would have taken care of by graphing and checking out to see if we actually got a 0 from it, we could see after this step that it is truly a factor because we are going to get no remainder. So, I say, what do I multiply x to turn it into 3x? Well, I think that one's a little easier. The answer is plus 3. 3 times x is 3x. 3 times 1 is 3. And upon subtracting this, I can see that they're identical, which will give me a 0 remainder. And that's an example of long division. Alright. And this would give me another factor, x squared plus x plus 3, which we will talk about how I can actually break that into two more factors, either by factoring or maybe by using the quadratic formula. Now, what I want to talk about is a shortcut. There is a shortcut to long division, but it only works with linear equations. Okay. Alright, and this is in fact a linear equation. So given the same concept, alright, given the same concept, okay, what we're going to do is this. Okay, what we do is we make a little box over here. And instead of writing the factor, we're going to write the 0. Alright, so if this is x plus 1, I'm going to write the opposite of this. I'm going to write my 0, where it would actually cross the x-intercept of a negative 1. Okay, and then you take every coefficient up there and you write it out. So the coefficient here is a 1. That's what's in front of x cubed. And then my 2, which is the coefficient for x squared. And then my 4. And then my 3. And the very first thing you do is you drop. So I'm going to drop this 1 down to here as a 1. And then you just go through and you start to multiply. So I say this. I say negative 1 times 1. I multiply the top, whatever's in the square, by whatever's at the bottom, and I rewrite it underneath my next term here. So negative 1 times 1 is negative 1. And once again, you add. Everything gets added. 2 plus negative 1 is 1. Multiply again. Negative 1 times 1 is negative 1. And once again, I add. 4 plus negative 1 is 3. Alright. And then I do one more time. Negative 1 times 3 is negative 3. And I can see that this right here has no remainder. So, since there's no remainder right here, I know I put an x, but these do cancel out. My answer is these are going to be the coefficients. And I can see 3 coefficients. Alright, so the 3 is going to be my constant. First power, second power, meaning I have 1x squared plus 1x plus 3. And there you go. It is a shortcut that I can use. I wish I could go back, but you can see what I did. Alright, let me just fix this really quick. Shouldn't take me too long. Erase that. Alright. Once again, 3, that's 1x, and this right here is 1x squared. So, synthetic division is used for a lot of things. Alright, it actually helps you find out the answer to some functions, but we're not going into that. What we're going to use it for is whenever we know a factor that is linear. So we're going to have x plus something, x minus something. Then we can use synthetic division to very quickly find additional roots. Okay? And that will finish off this. And I hope you guys have a great Easter weekend.